Okay, so section we're going to talk about zeros, then we're going to talk about intercepts, and we're going to talk about factors. So 3 things we're going to talk about today. Okay, so this first part of this says, use your calculator to graph the function f of x is equal to x squared minus 4x minus 5. Okay, so grab your calculator. Okay, and we are going to graph this. First, you have to turn your calculator on. There we go. Okay, so everybody knows that when you graph a function, you hit y equals. There it is. Phew. I was getting nervous for a second. Okay, so we're going to type in x squared minus 4x minus 5. X squared minus 4x minus 5. How do we do? You guys see that all right? Do you guys want me to turn on the lights so you can see it a little better? Maybe I'll cool it off a little. They're dead? Oh, so I need more batteries. Perfect. Alright, so the next thing that I want you to understand is that you're not the only person that uses that graphing calculator. And who knows where the person who used it last might have been, okay? I'm not saying physically, I'm just meaning on the calculator. So the window, if you hit graph, it might be zoomed into a super gnarly window, okay? So what you need to do the first time you get a calculator is you need to hit a zoom 6 so that it takes you into a standard 10 by 10 grid, okay? So if you hit zoom, which is right there in the middle on the top, and then choose number 6, which is a standard, we're going to have 10 units to the right, 10 units to the left, 10 units up, 10 units down. Okay, which is very nice. And we can see our nice, beautiful little quadratic. Okay, so the next thing that it asks us to do is it says, if you place your cursor on the point of the graph, you can see an x and a y value, and we're going to complete the table by using our graph. So, and instead of tracing our calculator, or tracing our function, which in my opinion is not very efficient, because if you hit trace and go along this thing, do you have nice whole numbers? No, they're not nice. But the calculator allows you to do some nice stuff. Okay, so if you hit second trace, the very first option says value. Okay, so guess what you're going to do? You're going to hit enter, and we're going to type in our values that we're going to plug into the function. Okay, so it's asking us, well, what x value do you want to plug in? We want to plug in all of these, so we're going to start with 0. So you're going to put 0 and hit enter. And did anybody else get an output of -5? Beautiful. So I will fill out this little table, -5, and I'll let you finish this for me. If you put 1 into that value, what do you get out? -8. What about 2? -9, so it's still going down. 3? Ooh, -8. Ooh, that means we must pass the vertex. Okay, and what about 4? -5. Perfect. Excellent. Okay, so I could use this table of values and plot a pretty nice quadratic equation if I was asked to plot some plot the equation, draw the equation, graph the equation. There it is. Graph the equation. Okay, but the next question talks about zeros. So it says, what are the zeros of the function? Does anybody remember talking about zeros in the past? Yes. Do you know what they are? Okay, they're where the function crosses the x-axis. Okay, now why on earth would the math people choose a word like the zeros of a function? I mean, 0, that's like a number that's so confusing, I just don't understand. Why do you think they would use the word 0 to represent where a function crosses the x-axis? Because what? It's when the y is equal to 0. Oh, okay, wait, now it makes sense. Okay, so all you do is you take the equation, you set it equal to 0. Oh, okay. So let's find the zeros of our function. Okay, so if I look at this, I can be pretty confident that my two zeros are what? Okay, so where it's crossing the x-axis, you guys thinking like, yeah, like -1 and 5? Does that look pretty good to you? Looks pretty good. Are we sure, like 100% sure? Or at least like a 90% sure? 96%? That's pretty confident. Okay, I'm going to show you how to be 100% sure using the calculator. Okay. All right, so let's say we're going to find this first 0, that one that looks like -1. Okay. Well, the calculator has the ability to find 0. So if you hit second trace, guess which option we're going to choose? 0. Whoa, you guys are so smart. Okay, 2. We're going to choose zeros. Okay, now down on the bottom of the screen, that left, it's asking us a question. And it says left bound. Okay, so it's asking us to go to the left of the 0. And when I'm thinking graphically, to the left means like less than, right? To the left are values that are less than. Okay, so I'm going to use my little arrow buttons, and I'm going to arrow over till I'm to the left of that point. And I'm going to be looking for the x values that are less than -1. Okay, so I'm flicking to the left, and I'm watching my x, and once it's to the value less than -1, so I'm at -1.7, that is less. Once I get there, I'm going to stop and hit enter. Now it asks me another question. What does it say now? Go to the right. Okay, so values that are to the right are values that are greater than. Okay, so now I'm going to push the right button until I see an x value that is greater than -1, and that looks good. And did you notice when I did that, my little cursor was on above the x-axis, and now it's below the x-axis? Did you notice that? Okay. So does everybody have two little arrows right here? No? Did you hit enter? Okay. We'll do it again. Okay, so make sure that your two arrows are pointing at each other. If they're not pointing at each other, then you're going to get a wrong answer, and it's going to say error. Okay, but once whoops, what did I do? Oh, I typed a number on accident. Delete. Okay, so once those two, okay, I guess we're going to try that again. I guess I got clicky happy when I wasn't looking. Okay, so left. There we go. And right. Okay. And then once the two arrows are pointing at each other, it says guess. And I'm just going to hit enter on the guess. I don't need to go and put my cursor there. It should be good. Okay, and what do you see? -1. Did anybody get a y value of 0? Oh, magic, right? Okay, so one of our zeros lies at -1. I'm going to write this right here, -1. Okay, let's see if you can find the other one. Okay, let's see if for surely it is at 5. So what do? I hit second trace, number 2. Okay, and it says go to the left, right? So I'm going to get my cursor, and technically right now where I am, it is to the left. It is less than 5, but I'm not going to hit enter yet. I'm going to get closer to it so the calculator doesn't get confused like I might be going for that other point. So, okay, that's a little close. Okay, so I'm on the left. So notice that my value right now is at 3.6, which is less than 5. I can hit enter. And notice that I am below the x-axis, so now when I go to the right, I'm I'm going to take my cursor above the x-axis. And I'll be right of that point. How far? No, not specifically. Okay, so then I hit enter. I take a look at my arrows and they are pointing at each other and I go, nice job, I did that right. So I hit enter. And did anybody get 5 and a y value of something crazy? What? I must have screwed that up. You guys screwed it up?
I got that the first time. Now I have 5.
Oh, it gave you a different answer the second time? That's weird. So is my calculator broken? Did I screw it up?
Both.
I screwed it up.
Actually, neither. Well, maybe the calculator is a little bit screwed up. Okay, so here's the thing that's happening. This is giving a value, and it's in scientific notation. You guys remember scientific notation? So it's telling me that this number right here is 1 times 10 to the negative 12th power. Anybody want to tell me about what that number is? It is a very small decimal, which is, I'm going to call it, that's 0. Are you kidding me? 1 times 10 to the negative 12th. Let's call that 0. So why does the calculator pop this out? I have no idea. It is a glitch in their operating system. But anytime you see an E like this, we're going to call that 0. Okay, so I have then used my calculator to prove that 5 is in fact a 0 of our function. Awesome? Okay. Do I need to do some more examples of how to do all that stuff? Okay, so all you're going to be asked to do is type the equation in, come up with your output values, and then draw a beautiful little graph of it. Should we do an example? Yeah? On the one above? For number 2? Oh, no, because, well, they're asking, like, definition-wise, like, what are zeros? And it kind of says, what is a crest? So it kind of, like, told me the answer and the hint, so I just skipped it and went to the part where I found them. Sorry, sometimes I do my own things. Okay. How about number 4? Let's skip. I'm going to skip number 3. I'm going to go to number 4. You'll see something like this on your homework. Are you ready? Should we do this together? No?
Yes.
Okay, so let's type it in. So we go to our y equals. So we're looking at our function x squared plus 2x minus 3. So that's what we're going to type in. So I hit y equals. I'm going to clear out that old one and type in my new one. X squared plus 2x minus 3. Okay. Do I need to hit a zoom 6 again? You don't have to. Would it hurt? It's just going to take me right back. I know I'm in a 10 by 10 graph. So I can just hit graph. Ooh, that's nice. Okay, so I need to fill out my table with all those values. So I hit. What buttons am I pushing? Second, trace, and which option am I using? The value, right? We're just putting the values in right now. Okay, so if you type in -2, what do you get? -3. Okay, I'm going to let you guys finish it for me. -3. What about when you type in -1? -4? What about 0? Ooh, I could have done that one in my head. How about 1? Ooh, a 0. Awesome. Okay, so I have 5 points. The next piece they ask me to do is they ask us to graph the function. So I'm going to make this easy on myself and take those 5 points and just plot them here on my graph. Okay, so I go to -3, 0, -2, -3, -1, -4, 0, 3, 1, 0, and wow, that looks good. If I don't say so myself. So, what are the zeros? Yeah, if they gave us some beautiful points that we found earlier, thank you, zeros. Zeros are at x equals -3 and at 1. That was very nice of them. Okay, pretty simple? Okay, let's go further. Okay, now, I don't know if I would write all of this part down, but I think this is an amazing explanation of understanding quadratics. Okay. So you remember on Tuesday, was that the last day I saw you? No, Wednesday. Okay, so I was like, okay, we're learning about quadratics, and there's 3 forms of quadratics. And then I showed you vertex form, and then I showed you standard form. And I didn't show you the 3rd form. Does anybody know what the 3rd form is? Not quadratic.
Oh, zero.
Factored form. Okay, you guys remember factoring last year? A little bit? I hope so, because we're going to do it again. Okay, so there's factored form. Okay, so factored form looks like this equation right here. See that? Y equals x plus 3 and x plus 1. Okay, so this is a quadratic. It's in factored form. There's 2 linear factors. See what that says? Linear factors right here. Linear factors. Linear meaning a straight line. Okay, so a function that is linear is like x plus 2, x minus 8, 3x plus 5 with an x. Those are linear factors, right? Okay, so you have 2 of those linear factors. Okay, so check this out. This is really cool, in my opinion. Sorry. Okay, so it says, graph the lines x plus 3 and then x plus 1. Okay, so if I asked you to graph this, you'd be like, oh, sweet, that's easy. I start at 3. So I go on the y-axis and I start at 3. So I make a little point right there. You can see where I'm at. Boop. Up 3. And then I say, oh, okay, the slope is 1. So I move up 1 over 1. And I draw a beautiful straight line. Perfect. Okay, and now I'm going to draw the line x plus 1. So I go to the y-intercept of 1, and I draw a little point. Okay, and then my slope is also 1. Interesting. That surely is. Same slope is parallel. Absolutely. Okay, and let's talk about the x-intercept here. Okay, where does my blue line, the x plus 3, cross the x-axis? What? The x-intercept, which is 3. Now, did you come up with that by looking at the graph? Okay, now what if I said, here's your equation, y equals x plus 3. What's the intercept? What's the x-intercept? Okay, if I'm asking you to find the x-intercept, I'm asking you to do what with the equation? Set it equal to 0. Remember, we're finding zeros. So if I set it equal to 0, do you see what they're doing here in this next step? We're taking the linear quantity, we're setting it equal to 0, and if I solve that, it gives me -3. That's my x-intercept. Okay, and if I take the second equation, x plus 1, and set it equal to 0, and solve it, I get another intercept at -1.
So this is just like number in place of x and solve.
Ooh, yeah, okay, sure. Okay, so you're thinking, yeah, the quick way to do that. Now here's something really cool, and I'll be perfectly honest. I've been teaching math for 12 years, and I've never seen this before. And now I look at this and go, God, it is genius. Okay, check this out. This is the piece, and this is what I would write in my notes, because my goodness, how simple of an idea. What are they doing here? They're taking these x-intercepts and doing what? Oh, say that louder. They're finding the vertex. What? Oh my gosh, that's so simple. Because the vertex is going to be exactly halfway in between those 2 x-intercepts. And why do I know they're halfway?
Because it's the
The axis of symmetry lets us do that. Oh my gosh, that's genius. Okay, so all I do is I take those x-intercept values, so -3 and -1. I add them together, so I get -3 plus -1 makes -4. And then I divide it by 2, and that gives me an x value of -2. Okay, so this is giving me the h of my vertex.
Like decimals and stuff like that.
Yeah, right? I mean, yeah, how often?
Right.
Okay, so how do I find my k value? How am I going to find it? How did they come up with this -1? How did they get there? Okay, it was exactly the same thing that we did in the warm-up today when we found the h value. The next step of finding the k is plug it in. Okay, so if we take, our equation is y is equal to x plus 3 and x plus 1. And we take our h value we found was -2. Okay, and we plug the -2 in, -2 plus 3, and -2, whoops, hold on, I screwed that up. Just got scared for a second. I wrote that down wrong. Plus 1 up here. Plus 1, there we go. Okay, so -2 plus 3 makes 1. And -1 plus, or excuse me, so -2 plus 1 makes -1. So what's my k value? Times. 1 times, there you go. -1. And that's where they got that -1. Genius. So simple. Okay. Da, 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 da. Beautiful. Okay. Let's do it our way. Okay, so now let's say here is your factored form, and they asked us to graph it. Okay, now I'm going to do it my way. I don't think it's necessary for us to graph the linear pairs. Okay, so I'm not going to make you do the linear pairs. I think that's unnecessary, but I think it's important that you understand why we would ever do that. So that was why I showed you that piece up above. Okay, so we're just going to go straight to the part where we find the zeros. Okay, how do I find the zeros in factored form? Okay, I set each of the linear pairs equal to 0. Okay, so I'm going to write this here. So finding the zeros, this is my step 1. Okay, so I'm going to take x minus 2, and I'm going to set that equal to 0. So my first x-intercept is at 2. So I've got 1 at 2. Then I'm going to take the other linear factor x minus 1 and set that equal to 0. And so my second one lies at 1. So I got 1 at 1 and 1 at, oh good lord, okay, those are very close together. So we got x, 1, and 2. Okay, so now if I'm graphing it, what's the next point that I need to find? The vertex. Okay, so how do I find the vertex? So now we're finding vertex. How do I do it? Find the midpoint, okay? So we're going to add the two x values that I just got. 2 plus 1. We're going to divide that sucker by 2. So 2 plus 1 makes, ooh, and 3 divided by 2 is 3 halves. Yep, 3 halves, not 1.5, 3 halves. Okay, so yeah, I'll let you get away with 1.5, but I like you guys to keep things in fraction form. Okay, so try to get used to keeping things in fraction form. Makes your life easier, I promise. I, Miss Nolte, promise. Fractions are, in fact, easier than decimals. How do I find the k value? Good, plug in 3 halves. Okay, so I'm going to have 3 halves minus 2 and 3 halves minus 1. Okay, we got to play with fractions, dang it. Okay, if I'm adding or subtracting fractions, what do I need to have? Common denominator. So what's my common denominator in all of these? 2, right? Okay, so if I need to have a 2 on the bottom of the other 2, What's 2 the same as in halves? Good. So I got minus 4 halves. Everybody okay with how we got there? Multiplied by 2. Okay, and what about 1? What's 1 in halves? 2 halves? 2 halves. Alright, so now we can just go ahead and combine those tops together, so I'm running over my little... So I have 3 halves minus 4 halves. What's 3 halves minus 4 halves? Negative 1 half. Just add the tops. And 3 halves minus 2 halves. 1 half. And now when we multiply straight across, we get the k value of negative 1/4. Oh, good lord. Okay, so our vertex we found to be 3 halves and a negative 1/4. Perfect. I can plot that. I'm good. I got this. 3 halves and a fourth. Perfect. Oh my gosh. Oh, that is good. How do you guys feel? Really good? Oh, good. Okay. So, over on this side, they kind of go about doing it slightly different. Okay, so they would have said, once you have your vertex, let's write this in standard form. Okay, now, I need to know if I need to go over how you would put this in a standard form. Okay, if I'm given factored form, how would I get to standard form? Yeah, FOIL. Do I need to go over foiling? Yes or no?
No.
Anybody want a yes? Going once, going twice. Okay, so just putting it in standard form, we foiled, add your like terms. Okay, and we graphed our quadratic. Perfect? One more? You guys want me to do one more? Yes? Who wants one more? Okay. Here we go. I don't have another example, so I'm going to make it up. Sorry if this gets gnarly. Example 2. Y is equal to x minus 4 and x plus 6. Woo, that'll be perfect. Okay, so can I go straight to quickly finding my 2 X-intercepts? Anybody see it right off the top of their heads? 4 and negative 6. Everybody follow that. Anybody like, what? Okay, so I'm going to go and I'm going to plot those 2 points. So I go to 4, 1, 2, 3, 4, negative 6, 1, 2, 3, 4, 5, 6, 7, oops, 6. Got excited. Okay, so I got 2 points. I need my vertex. How do you find the vertex? Okay, so I find the h by adding the 2 intercepts, dividing by 2. So 4 plus negative 6 makes a negative 2 divided by 2. Oh, that was so nice of me. 1. Okay, so I got the h. How do I find the k? Plug it in, plug it in. Oops, sorry, negative. Thank you. Minor details. Sorry, no, that's a big major detail. Okay. Negative 4 minus 4. I know I said that wrong. Negative 1 minus 4. And, ooh, interesting. Negative 1 plus 6. 5. That is interesting. Okay, so negative 5 times 5. Ooh, 20. Oh, good lord. Okay, so maybe this wasn't a great example. Okay, so negative 1, that's negative 25. Perfect. And done. I did not draw good lines on that. But you get the gist? Is that okay? Okay. Last idea. Well, what the heck do we need to know all this for? It always comes back to this idea. Can we solve the equation? Okay, So what is the difference between the functions that we were just working with and solving an equation? So like, for example, this is an equation right here. What's different from this compared to the ones we were working with? Like, I was just talking about this piece up here. Okay, yeah, we get rid of the y and we put a number in there. Okay, so now we only have one equation and we're solving for the x value. Okay, so it's set equal to 0. Now all of these ones are going to be set equal to 0 today, which is going to be really awesome. Okay, and all we're going to do is we're going to solve these quadratic equations that are going to be set up for us in factored form. So I'm going to go straight down to here. If this is set equal to 0, what are we essentially doing? Finding the zeros, right? We're finding the x-intercepts, which is like what we did in the last section. And so now we're just kind of like doing kind of less work. What are my two solutions to this equation? 6 and 3. Okay, number 2. What are the two solutions to this equation? -8, +5. Do I need to keep going? Because I have a lot of examples. Good? Literally setting each of them equal to 0. Good? Done with me? You're sick of me?